stream. So, House Algebros, could you please do your explanation of your problem?
I just did, teacher. You didn't hear me.
I know, but we're recording, so I just clicked record.
Ah.
So, okay, take two. House Algebros, could you please do your brief explanation of your problem?
Okay. So problem 30 says that we have to find the distance between point A and point B. So to do this, we just use that formula to calculate the distance. That is this one right here. So we just substitute the x's and the y's with the numbers that problem gives us of point A and point B. And the answer is square root of 65, or if you solve that, it's 8.06.
That's perfect, Fernanda. Thank you so much. I had a deja vu, like I had heard that before, but we hadn't, because this was the first time. I just want to make a couple of comments. Well done. I just want to make a couple of comments because of the topic. So this first topic has to do with the distance between 2 points. Now, all of you should have watched the video I sent with regards to this topic. And so basically the distance between 2 points, we're actually using the Pythagoras theorem, or a version of the Pythagoras theorem, to create a sort of triangle here. Whoops. To create a sort of triangle here. And based on that triangle, we calculate the distance, which is the hypotenuse. And we do that by using the coordinates. Now, something very important when we use this mathematical expression for the distance between 2 points, which is this one that you've got here, is that we always have 2 points, point 1 and point 2. So it's very important to be congruent. So right now, for your analysis, A was 0.1 and B was 0.2. So that's important because you're doing a subtraction. It's x2 minus x1 squared plus y2 minus y1 squared. So the order in which we do those for these expressions is important. And the rest are just calculations, okay? Well done, okay. Thank you very much, Fernanda and House Algebras, okay? Well done. The first, I believe, 2 or 3 problems are that they're very straightforward. Let's see. Let's go with Deathly Hallows.
Teacher, I sent you a message to chat.
Yes. I'm answering him. I'm going to answer quickly. No, don't worry, Marco. No worries. Just next time, send me a text to know what's happening. Okay. No worries.
Yeah, sorry. She just yelled at me like, "Calm down and help me," so I couldn't do anything.
Don't worry about it. I'm doing this. I was muted a few minutes ago while Fernanda was speaking because he was crying. So I understand. No worries. Okay. Just send me a note so I know what's happening. Okay. Thank you, Marco. Let's go then with problem 32, which is very similar. Go ahead.
Okay, so on problem 32, it says to find the distance between point A and point B, which is right here. So we use the formula of square root x2 minus x1 multiplied by 2 plus y2 minus y1 times 2 as well. So here
it's not times 2.
No.
That would tell me that you're just reading what's on the slide, and then what's on the slide is correct, but it's not times 2.
Huh?
It's not times 2. Can somebody help Miguel out?
Is that not the formula?
No, it is the formula. You're reading it incorrectly. It's not times 2.
It's called.
It's
square.
Power
by square. Power by 2. Sorry.
Perfect.
Power by 2.
Perfect. There we go. Go ahead.
So by just substituting the whole thing, we get the answer of 23 square root, or if you solve that, we get 5.09.
Perfect. Thank you, Miguel. That's basically, again, we're applying the formula. The thing to remember here, the same. Don't remove the the slide. Important to remember, this would be point number 1, and this would be point number 2. We have to be careful with the signs when we apply the sign. So the way you guys solved it, where you've got a parenthesis that maintains the sign, is important. Okay,
Yes.
because the sign is gonna multiply, and we might have an addition instead of a subtraction. Okay, these two problems are very straightforward. It's just directly applying the formula of the distance between 2 points. Okay, well done, well done. Thank you, guys. Thank you. And let's see, we've got house pi waves. You got problem 36. Go ahead. Let's see, the next team, we've got Leo, Luis, Jesus, and Alejandro. We've got problems. There we go. Perfect. Go ahead.
Mister, can you hear me?
Yes.
Oh, okay. First, we have the problem that is determine whether the points A, B, and C are vertices of a right triangle or an isosceles triangle, or both. First, we look for the distance between the points. As we can see in the right, we look for the distance between A and B. And first, we use the formula for distance. I don't remember right now, and I forgot to put it in the presentation. But there is a procedure. I think it was square root of parentheses x2 minus x1 parentheses close to the square plus y parentheses y2 minus y1 close parentheses x squared, and it's like there is represented like 1 minus the negative 4. Well, it's minus, and then the 4 squared plus 1 minus 0. Then we got negative 3 squared plus 1. We got 6 plus 1 in the root, and finally the distance is square root. No, yes, no. Yes, square root of 7. And that we did that in the following 2 points from B and C and C and A. And at the end, we can tell that A, B, and C are vertices of a right triangle with the right angle of the point B that is represented in the graph at the left. It cannot be an isosceles triangle because all the sides have a different distance, and I think an isosceles triangle have 2 sides has to be equal.
Okay, let's analyze this a little bit. Okay, don't remove the slide. Okay, they're giving us three points. Okay, in the Cartesian plane. Now there's a rule here. So I'm going to ask this question. Anybody can answer. You can answer. He butts in when he wants to. So if I have 2 points in the Cartesian plane, what's the geometric figure that's automatically always going to be generated? If I have 2 line, correct, perfect. If I have 3 points in the Cartesian plane, what's the geometric figure that's automatically going to be always generated?
A line or a triangle?
A triangle. Good observation there. Good observation. It's a triangle or a line because the 3 points can coincide. That's a good observation. Now, if you've got 4 points, 5 points, etc., it's going to be a polygon. Okay. Now, if we've got 3 points, A, B, and C, then there's going to be a triangle generated. And we know that there are different types of triangles. The right triangle is a triangle that between 2 of the sides, there's a 90-degree angle. The isosceles triangle is a triangle that has is a triangle that the two of the sides are the same. And by the way, an isosceles triangle could be a right triangle as well. Okay. And what's the last type of triangle where all of the sides are different?
No, I just know how to say it in Spanish. That is
It's weird in English. Say it in Spanish.
equilátero.
That's all the
No,
same.
no,
No,
no, no,
oh,
that's
you
all,
just, oh, you said different? I thought you said the same.
all of the different. That's scaleno.
Scaleno.
Scalene. It's very weird to pronounce it. That's when all of them are different. So now we're trying to identify what type of triangle it is. And so one of the tools we can use we can graph. It's good that you guys plotted it here, but maybe in the plot or the graph, we're not going to be able to exactly see certain things, but we can use the distance formula to identify the characteristics of the triangle. So I'm going to assume that the calculations are correct. Okay. So you've got the distance. I'm just going to mark this here and let me know if I'm correct. But from what I'm seeing for you guys, this point is A, this point is B, and this point is C. Is that correct?
Yes.
Right. Okay. So this calculation here, this is correct. This is the distance between A and B, which is the square root of 7. Okay. And let's see if we did that correctly. So A is 4, 0. B is 1, 1. And C is 2, 3, right? So if we're doing A and B, it's going to be 1 minus 4 and 1 minus 0, okay? And this is going to give us a square root of 7, correct. Then B and C, we've got 2 minus 1, 3 minus 1, 2 minus 1 is 1, 3 minus 1 is 2, 1 squared plus 2 squared, that's 5. This one is correct as well, right? And then we've got the distance between C and A. It's going to be 4 minus 2 and 0 minus 3. That's going to be 2 and 3. We've got a little, your answer is correct, but there's an error in the calculation here. Did you guys?
I forgot to put the square. I noticed now.
Yeah, but your result, you have to be very careful. Your result was correct.
It's because I copied it from my notebook.
Yeah, your result was correct, but if I took these values, square root of 7, square root of 5, and square root of 10, it's not a right triangle. It's not a right triangle. And it's not an isosceles triangle either, because a right triangle has to comply with the Pythagoras theorem. And square root of 7, square root of 5, and square root of 10 do not comply with the Pythagorean theorem. However, if we do the correction here, this is 4 plus 9, okay? 4 plus 9 is 13, right? Let me just check. 13, right? This is equal to the square root of 13. Are we okay up to that point? Slight correction we had to do there. Now let's look at the analysis. First off, this assumption is correct. We've got another. Okay. We've got another mistake. Did you guys notice it?
No.
Where's the other? I'm going to call them finger mistakes, translated to Spanish. Where's the other mistake that we've got in the calculation? Well, we don't know which one it is. Look at the calculations. We've got another mistake up on top.
The 3 squared.
3 squared. Yep. So this is a 9. And 9 plus 1, this is the square root of 10. Okay? Right? Are we okay up to that point?
Yes.
Just double check the other one. 2 minus 1, 2, 1, that's right. Okay. So now we've got square root of 10, square root of 13, and square root of 5. Now, the affirmation that we have in the bottom, it's not an isosceles triangle, because for it to be an isosceles triangle, two sides would have to be the same. And that's not happening. All of the sides are different, right? Now, how do we verify if it's, how do we verify if this is a right triangle? It has to comply with the Pythagorean theorem. And the Pythagorean theorem says that the sum of the squares of the smaller sides has to be equal to the square of the larger side. Which is the larger side? Square root of 13, which is the smaller side, square root of 10 and square root of 5. So this means that the square root of 5 plus squared plus the square root of 10 squared would have to be equal to the square root of 13 squared. And this is equal to 5 plus 10, and this is 13. Is that equal?
No.
Nope,
You.
this is not equal. Yes, go ahead.
May I go to the restroom?
Yes, go ahead. Yes. So this is not equal, you see?
I don't get it.
So therefore, this is not correct. So it is neither. Okay, this is neither right or isosceles triangle, assuming that the calculations are correct. Okay. Questions with this one? Was that clear?
Yes.
Yes. Let me don't move the slide, please. I'll just take a quick screenshot here so we can add these to the corrections. So we just have to be a little bit careful with the calculations, neither a right or isosceles triangle. There we go. Okay, questions before we move on?
No.
Okay, have to be careful with the squares there. They can be tricky. Okay, good. Thank you. Thank you, House High Waves. Let's go over to House Jokers. You've got problem 38. Please. So you may stop sharing. While we wait, just as a note, I'm carrying little JD because my wife has to go to a doctor's appointment, and my daughter isn't here. Or my daughter isn't here with me, and I'm obviously not going to leave the baby with my daughter. And babies have a thing called, in Spanish, it's called embrasilados. There's a term in English for it. I don't remember the term, which is basically that the baby cries if you don't carry them. And so he's kind of like that. But we've gotten to the following conclusion. We don't care if he's embrasilado. So if he wants us to carry him, we're going to carry him. He's just not going to sleep with us, because they stay this little for so little time. Before you know it, they're old and they're in university and they're asking you for the keys to the car and stuff like that. And so yeah, let's take advantage of them when they're little. So that's why I'm carrying him. If I leave him right now in the bouncer, he's going to start crying. That's not cool. That is not cool. Okay, go ahead. House Jokers.
So in problem 38, we have to get the distance between these 3 points. So first of all, we have to know the formula to get the distance between 2 points. And first we found the distance between A and B. So we have to replace the values given and give us the square root of 25, and it's equal to 5. Then we have to get the distance between B and C, that it's the square root of 5. It's equal to 5, and C and A, it's equal to square root of 98, that it's equal to 9.9, and it's an isosceles triangle.
Okay, thank you, Ayman. And so this problem is the same as the other ones. We've got 3 points and we're trying to find out if it's right or isosceles or both. In this case, we do the calculations of the 3 distances, and we clearly find that 2 distances are the same. That would mean that by default, it's an isosceles triangle. It is not, it would not be a right triangle because if we, and I'm just going to write this down here just as a note, it's not a right triangle because it would not comply with the Pythagoras theorem. So if we write the Pythagoras theorem here, the squares of the smaller sides would have to be equal to the square of the larger side. And so that would mean that 25 plus 25 is equal to 98. And this is not true. Okay, this is not true. And so since this is not true, that means it's not a right triangle. It is an isosceles because 2 of the sides are the same. It's not a right triangle. Okay, good job. Well done. Well done. Okay. Let's go with, remember that we're going to go long. So we finish up on time so you guys can go to your Spanish class. So we're going to go long. So if anybody needs to take a bathroom break or drink some water or whatever, then go ahead. We're going to continue. Let's continue now. We're going to go back with house algebras. Now you guys have got problem 42.
Yes, teacher, can you hear me?
Yes, perfectly.
Okay, so we have to use the distance formula to determine whether the points A, B, and C lie on a straight line. So the first step to do is to find the distance between every point by using the distance formula. And the procedure goes as follows. We do 4 points B, C, and it gives us the square root of 40. We do 4 points A and B, which gives us the square root of 90. And we do 4 points A and C, which gives us the square root of 250. Now, by having these distances, we can establish a relation. If the distance between point A and B plus the distance of point B and C are equal to the distance between point A and C, those points lie on the same straight line and they are collinear. So we have to add the square root of 90 and the square root of 40, but there is no such thing of adding 90 plus 40 and getting the square root of that. So we need to find the same number inside to make them be able to be added. So we get 3 square root of 10 and 2 square root of 10, which gives us the 5 square root of 10. And with the point A to C, it's the square root of 250, which is also the same, 5 square root of 5. So now that we have that, we know that all the 3 points are collinear and they're in the same straight line.
Perfect, perfect. Well done. Well done. Oh yeah, good. I was going to draw. You drew the line. That's perfect. Well done. I'm going to comment here, taking advantage that you drew the line. I was going to actually draw the line. if this is important, it's good that that you guys did the plot for this one and the previous one. Why? Because the next topics from Unit 2 are going to be heavily based on graphing and plotting functions. And so we need to be very familiar with the Cartesian plane. And so basically, if we plot the points, we're going to notice that the points are located in a certain sequence. And so if we've got point A here, point B here, and point C here, then basically we've got three distances. This is distance AB. This is distance BC. And then we've got the larger distance here, DAC. And so we could have done all of the combinations of distances and follow the same rule of the collinearity. And basically what should happen if they're in the same line is that the sum of the shorter distances would have to be equal to the sum of the larger distance. And that occurs after we do the calculation. Good job with the rationals and using the rational expressions and factoring there, so you didn't have to really do any calculations. Good job there. Good job. Okay, well done. Well done. Let's go now with House Deathly Signs with, you guys have problem 44. Go ahead.
Give us a second, teacher. We're trying to share the screen.
Okay.
Okay, so for
Alright.
problem number 44, to solve this problem, we need to use a distance formula, and we're gonna use it on both coordinates, and let's call them A and B. We have to find which coordinate is closer to the origin, which would be basically 0. In the first coordinate, we get, after using the formula and solving the equation, we get the answer of 0.98. And in coordinate number B, after using the formula, we get the answer of 1.001. Here, if we look at the answers, we can tell which one's closer to 0. In this case, would be 0.98, which would be coordinate A. And that's the answer. Coordinate 1 divided by square root of 2, comma 1 divided by square root of 2 is the closest to the origin.
Yep, well done. Could you make it a little bit larger, the slide? Perfect. Yeah, and so basically we've got 2 points, and they're asking us which is closer to the origin. So basically what needs to be calculated is the distance between each point to the origin. So point 1 is going to be the point 2 is going to be the origin. We do the calculation directly and we find that which one is closer. Well done. Perfect. Again, the only thing we're doing here is practicing the distance between 2 points formula. And this topic is actually, again, it's important because it's a preamble to the graphing of functions topic that we're going to be seeing in the next few sessions. Okay, well done, you guys. Let's go with House Pi Waves. You guys have problem 48.
Okay, so the problem is number 48, and the question was to find the midpoint, which sum of the line segment joining the point A and B. So the formula for finding the midpoint is m times m, and the coordinates will be, the first coordinate you can get it by adding x1 plus x2, and then divided by 2, the same, and with y as well. So substituting in the formula, it was 2/3 plus 7/3 and divided by 2. And now with the y's, it is 1 plus minus 3 divided by 2. And now getting solving the formula, the answer was the first coordinate will be 9/3 divided by 2, and the other one will be -2 divided by 2, which is -1. So the final answer will be that the coordinates of the midpoint is 3/2 or 3/2, comma, -1, or it can also be showed as 1.5, comma, -1.
Perfect. This is a relatively very simple problem. Basically, the concept here is the distance, the midpoint between two points in the Cartesian plane.
Following the formula.
And basically the midpoint, we calculate that, if you notice, it's the average. It's the average of the x and the y, okay? And that's how we calculate it, and it's this expression that we have here with the
Yes.
uppercase M. Okay, well done, well done.
It's the same if you're in the represented as a fraction or as a decimal.
Yes, yes, both are correct. Both
Thank
are
you.
correct. Perfect. Well done, well done. Okay, good. Things are flowing relatively well. That was 48. Then we've got house jokers with problem 50.
Okay, so problem 50. We have 2 points. Point A, which is 1 divided by 2, comma, -3 divided by 2. And we have point B, which is -5 divided by 2, comma, 1. Well, our first step is to use the formula to find the midpoint, as always. So we're going to have a half plus -5 divided by 1. The divided by 1 is so that we can make the subtraction easier. And then this is going to be divided by 2, and then -3 divided by 2 plus 1 divided by 2. Once we solve both of the sums and subtractions, we get -2 divided by 2, comma, -1/2 divided by 2. We solve these divisions, and then we have the final result, which is going to be -1, comma, -1/4.
Okay, good, good. I just want to double check here the calculation. So it's 1 divided by 2. I just want to check if we don't have a detail here with. Give me a moment. Give me one moment. There we go. Let's just check there the value. So it's 1/2 divided by, no, 1/2 plus -5 divided by 1, and it's -5 divided by 2. And then it's -3 divided by 2 plus 1. That's correct. But I'm not sure if we're missing here. Let's review this calculation here. There, right there. Yep. So I check if it's so here we've got a 2. Okay, so if we do that, then we would have -4 divided by 2, which would be 2. Yeah, so the end result is correct, right? The end result is correct. That was just a finger mistake though, right? right, you guys?
Yeah,
Yeah,
it's
yeah,
two, not a one.
yeah, but the end result is correct, okay?
Yeah.
Okay, okay.
Thank you.
Good, let me just, give me a moment, let me just take a quick screenshot here. So I can correct it in, okay, there we go. Okay. Okay, good job, you guys. Let's go over to, that was problem 50, right? Let's go with problem 52 then with house algebras. No, that was 52, right? No, that was problem 50. Yep, let's go with problem 52 with house algebras. There we go.
Can you hear me?
Yes,
Okay, so problem 52 states to find the midpoint M of the line segment joining the points A and B, when the points are X, B, for A and B is negative X and X plus 2. So the first step is to identify X1, X2, Y1, and Y2, which is the equation for midpoint. Once you identify each one, you implement it into the equation, which is X plus negative X divided by 2. And then it's X plus 2 divided by 2. Next step is to solve the equation, which equals to 0. And then 2x plus 2 divided by 2. After you divide the answer, you get your final result, which is M equals to 0, X plus 1.
yep, good job. This is an example where there are variables there that we don't know the value. Just a note here, and that's just because of me, it's not necessarily a deal breaker, but be careful here with the parenthesis.
Oh, yes, I see.
Yeah, just so we don't confuse that. Everything is divided by 2. Okay. Otherwise we're good. Okay, good job, you guys. Good job. Okay, let's go with house definitely signs. You guys have problem 58. Who's hungry? That's a baby being fed. The last 3 problems had to do with written problems. These we're gonna have to think a little bit more through them. So there we go. If you could make the slide fit the screen, that would be great.
Screen?
Yeah, that would be better. That would be better. Just because there we go. That I think that's readable. That's fine.
Okay. Just let me make it a little bigger. Is that better? Okay, so it says right here to find all the points in the x-axis that are 3 units from the midpoint on the line segment joining 5, 2 and minus 5, 6. So here we should have another point right here and another point right over here, I think, right? And so what we did was to get x1 plus x2 divided by 2 and y1 plus y2 divided by 2. This is a formula to find the midpoint. So we got this, using the formula, we got this point right over here. And so what we did was to move the other 2 points, like 3 units to the left and 3 units to the right. So we got the 3 units from the midpoint that the problem asked for us, which is -3 and -2 and 3 -2.
Okay. Okay, we're gonna have to
I
do
think
a,
right here that there is a finger mistake.
there's no, actually, well, we're gonna review that, but actually there's a little detail here that has to do with interpretation of what the problem is asking. Okay, and we're gonna correct that. Okay, so give me a moment here. The midpoint. So the midpoint, we calculated the midpoint. That's correct. You grab the 2 values 5 and 2 and minus 5 and minus 6. And you've calculated the midpoint. And I think that calculation is correct. Is 5 minus 5 is 0. And 2 minus 6 is minus 4. Divided by 2. So this is correct. This is the midpoint. Now, what you said after that is it's 3 units from the midpoint. And you said, all right, it's 3 units from the midpoint. So what we're going to calculate is 3 units. The midpoint is 0,2. It's 3 units to this side and 3 units to this side, right? However, that's not what the problem is asking. What the problem is asking is find all the points on the x-axis, okay? Give me a moment. Okay, so what the problem is asking us, it's find all the points on the x-axis that are 3 units from the midpoint. So the midpoint, that's correct. We just found the midpoint. This is the midpoint right here. This is the midpoint, that's correct. But what we're looking for are points along the x-axis. So actually we're looking for points along this axis where the distance is 3. So actually what we're looking for is any point along the x-axis where this distance equals to 3. Now I'm putting it on both sides because the distance could be on either side. Is that clear? So it could be here or it could be here. Okay, so that's what we're looking for. So actually, once we've found the midpoint, then we're looking for a spot here on the we're looking for a spot here on the x-axis. I'm just going to mark it. I'm just going to mark this one here. If this point is in the x-axis, it means that it's a point called x, comma 0. Okay, why is it x comma 0? We don't know the value of x. And since it's in the x-axis, the value of y is 0. Is that understood? Questions up to that point? Okay, so now what we need to do is to establish an expression of the distance between those 2 points, and that has to be equal to 3. So the distance, which is equal to 3, has to be equal to the square root of x minus, what's the value of x? X minus 0 squared plus 0 minus 2 squared. This would be equal to having the square root of x squared. And this is going to be 2 to the square, which would be equal to 4. And this would be equal to 3. Okay. I can elevate everything to the square on both sides. And this would give me x squared minus 4 is equal to 9. This would mean that x squared is equal to 9 plus 4. And this would mean that x squared equals 13, which would mean that x is equal to the square root of 13. But remember that the square root is plus minus. So that means that the 2 points we're looking for are going to be the square of 13 comma 0 negative, and the square of 13, 0. These would be the points that are of a distance of, oh, please don't move the slide. There we go. I need to take a screenshot for that. That would be, those 2 points would be the distance. Those 2 points would be points that comply with the distance being 3 units. And the key here is that it says that find all the points on the x-axis. This is important because we're going to be seeing a lot of things that have to do with graphing plots in the Cartesian plane, that we're going to be seeing a lot of that in unit 2. And so it's important. When I say it's along the x-axis, it means that it just has a value of x and y is 0. If I would have said it's along the y-axis, that means that it has a value of x equals 0 and a value of y. So along the x-axis means x comma 0. Along the y-axis means 0 comma y. Okay, is that clear to you guys?
Yeah.
Okay, good. Thank you. Okay, I've taken a screenshot of this so we can do the corresponding corrections. Okay, let's go with house pi waves. You've got problem number 60. By the way, please, while we're doing this, please send me via the Zoom chat. Please send me your PowerPoint presentations. Please send me your PowerPoint presentations now of each of the houses here through the chat. Remember that I do the corrections and I upload them to Blackboard. Send them here via the chat right now, please. And let's go with house pi waves with problem 60. Go ahead.
Who's gonna say it?
Who's going to talk?
Can
Can you hear me, teacher?
Yes.
So 160 says that consider the line segment joining the points A, which is in coordinates 0, 0, and B, 6, 0, and find a point that will be C in the first quadrant, such that A, B, and C vertices are vertices of an equilateral triangle. So we know that the coordinates of A are 0, 0, and the coordinates of B are 6, 0, but we don't know the coordinates of C. So we know that the top vertex of an equilateral triangle is exactly in the middle of the two vertices in the base of the triangle. So we get the midpoint, which will be using the midpoint formula, and we get that the midpoint is 3, 0. So we now have the coordinate of x of the C point, and we know that the distance between A and B is 6, and an equilateral triangle has to have all the sides of equal distances. So we need to find a value on y that gives a distance of 6. And we substitute the formula for distance with the values we know. The distance will be 6 equal to the square root of 3 minus 0 squared plus y, which is the coordinate we don't know, minus 0 squared, and we do the operations. So we take the square root to the other side like an exponent. So 6 to the power of 2 is 36, equal to 3 minus 0 squared plus y minus 0 squared. And 3 minus 0 squared is 9. We take the 9 as a subtraction to the other side, and we get that 27 is equal to y minus 0 to the power of 2. Then that would be 27 is equal to y squared, and we take the root, the power of 2 to the other side as a root, and we get that y is the square root of 27.
Perfect. Well done. Well done. Don't remove the slide. I'm just going to mark a few things here. So what you did basically is say that you've got point A here, which is 0, 0, and you've got point B here, which is 6, 0. So the midpoint is 3. And so, but the distance is 6. And so there's got to be a point over here in Y where this distance is 6 as well. And this point here has to have the coordinate 3, y, right? Because you've identified the midpoint, okay? Well done, well done, well done. Again, just a recommendation for everybody, because we're going to be practicing doing the graph and locating the points is useful, but well done, well done. Good job, you guys. Let's go with the last problem. We've got house jokers with problem 62. Which is a road trip problem, if I'm not mistaken. Okay, if you could make it a little bit, yeah, there we go, perfect.
Aguanta. Ya regresé la luz, pero
Are we landing a plane or something? That sounded like a tower control. Over. We're landing. Yes, ready. Go ahead.
Luis. Oye, ¿qué pasó con eso?
Teacher.
Te prendieron el micro.
Teacher.
Yeah, the mic is on. What's
We're
up?
having some technical difficulties. The members of my team are losing internet connection. And so we're having to use creative means to communicate.
Okay, that's fine. No, that's totally acceptable. But go ahead with the explanation. Oh, perfect. Yeah, it's important to know the context of the problem. Go ahead.
Okay, so for
Yeah, but we've got the echo.
Yeah,
We've got the echo situation.
okay, so for this problem, we're giving 3 different cities and the distances in between them with the cardinal points. So we have to first trace the 4 cities that we're talking about in the graph in order to have a general idea of what we're dealing with. Then we have to find the distance in between Kansas City and Des Moines by substituting our X and Y values, giving us, after doing all the procedure, 184.39 meters, miles. Okay, so next we have to find the distances in between the other cities, which is DM and I don't know what the other one was, but it was Chicago, yes. And so we have to substitute our X and Y values like we did before, based on the graph. And we get that the distance is the 330 miles. And then we have to substitute Kansas City with SL, which I don't remember which one it was. By substituting our X and Y values and getting the result of 233.45 miles.
Okay, next, we have to use Kansas City with our other city and substitute the values just like we did before. And we get the answer of 172.95 miles. And now we have to compare the distances in between the three cities like the problem was asking us. So we have 504.39 miles and 506.4 miles. And so we can tell that the distance from Kansas City minus and Chicago is the shortest distance in between both of them.
Okay, good job. Good job. Basically, we've got two cities that aren't connected directly. You have to do a connection between a middle point, either Des Moines. It's called Des Moines. It's one of those names. Remember that in the United States, there are a lot of names that are French, in Spanish. Des Moines, I think it's probably French origin. So you can either go Kansas City, Des Moines, Chicago, or go Kansas City, St. Louis, Chicago. Could you go back to the previous slide, please? Where you have the drawing. And so you've got a polygon there, and basically we want to know which is the shortest distance. So we calculate the distance between each of the points, and then we just compare the distances on each one, and we get, can you go to the next one? We get that the better distance is the better route is Kansas City, Des Moines, Chicago. Okay, perfect. Well done. Well done. Thank you, guys.